Hello, and thank you for joining me today. My name is Cameron Byers, and I'm a Principal Solution Architect here at Concourse Labs. We're a fast-growing startup, and we're recently named a Gartner Cool Vendor for our work in continuous compliance automation. Today, we're going to be talking about policy as code. This is a topic that's been gaining increasing attention within the ONUG community and is core to ONUG's Automated Cloud Governance Working Group. While policy as code isn't necessarily new, the need to continuously check and automatically enforce policy at every stage of the cloud application lifecycle is a new requirement. During this session, I'm going to share 4 best practices for operationalizing policy as code in order to solve the cloud dilemma of security while maintaining speed and agility. First, I'll demonstrate how to easily manage an increasing library of blueprints, patterns, and best practices that come from different sources. Second, we'll look at highlighting the critical capabilities necessary to easily customize standards and author new policy as code, as well as what you need to test, audit, govern, and manage it, since policy as code is much more than the basic coding of the control policy. Third, I'll show you how to prevent automated policies from triggering false alerts by applying context to ensure the right policies are applied across a complex organization with its many different and unique requirements. And lastly, I'll demonstrate how you can use automated policy as code guardrails to prevent non-compliant code from ever being deployed and exposing you to risk. So cloud standards can come from many different sources, including cloud service providers such as AWS or Microsoft Azure, CIS and CSA organizations, and you may even have partners writing custom standards unique to your organization. How are you going to be managing all of that policy content and verifying your controls are actually being met? Unfortunately, many organizations still rely on spreadsheets, such as this one, with more than 100 different Azure controls. This method simply is not effective or scalable for most organizations. Controlling cloud risk requires a comprehensive policy as code management system in order to ingest, customize, and manage your various blueprints, patterns, best practices within your own risk frameworks. One way to do this is to establish a policy bank or clearinghouse of catalogs like the one you see here. This type of system not only allows you to easily manage a growing set of policies, but also enables you to quickly benchmark your cloud risk posture. While benchmarking against industry standards makes sense, most organizations I speak with must customize these standards to meet their unique or specific needs. However, in order to write policies to achieve your control objectives, you'll likely need a rich policy editor. To illustrate why, let's look at a simple policy written in Rego. The policy you see is one that was written to ensure that PII data is protected with encryption. This policy basically states that data in the MS SQL databases for transparent data encryption must be encrypted with a key protected from an HSM key vault. However, creating this in Rego requires that the author to already know the available Azure resource types, properties, and string values that must be checked in order to meet the policy objectives, as well as how to write that policy logic. As you can see here, there's no easy way to validate the specific cloud resource or its properties. In stark contrast, a rich policy editor can automatically aggregate and verify all available resource types and parameters for you. Now let's look at creating the same policy within an editor like Concourse. Unlike in the previous example, here all of the available resource types have been validated against the Azure API. This includes the specific relationships between MS SQL Server, transparent data encryption, and the specific Azure Key Vault we want in order to ensure RSA HSM is enabled. This makes the policy logic much easier to author, as policies are written in the cloud native language. This is key to eliminating policy errors that result in controls not being checked. An editor must continually ingest the cloud provider's type system in order to ensure your security and risk management always remains up to date as the cloud changes. And because it's imperative to treat policy as a first-class citizen, we version, track, and control every change to keep a detailed and comprehensive audit log for every policy across its entire lifecycle. Now that you've created a set of codified policies, understanding where to apply them becomes critical. As you automate your policy checks, you're going to want to avoid alert noise and risks, which can be created from blanket enforcement of the same policies across multiple different geographies, application stages, and business units, each having their own unique requirements for compliance or best practice. Now let's look at an example here to illustrate that point. Here we're seeing a set of applications and data in our cloud environments that are subject to different regulatory oversights. With this framework, you can easily associate applications subject to PCI with relevant PCI policy without subjecting applications that aren't governed by a PCI to those same standards, while also ensuring that each application, regardless of the specific regulatory jurisdiction they fall under, adheres to a common set of requirements, possibly based on their geographical usage. Another common need I see is related to assigning different policies across different phases of an application's lifecycle. After all, what's acceptable inside your development sandbox is very different from what you'd ever allow in the production. Like our previous example, this type of policy hierarchy allows you to apply different policies for development and production level applications, while ensuring that all applications, regardless of stage, meet a core set of your global requirements. Applying policy as code in this manner not only eliminates false positives and negatives, but also dramatically improves your response times, since not only are those people who are responsible for, say, production applications in the US, they're immediately notified and tasked with remediating the risks for those specific environments. And since we're automating control compliance, you're also going to automate the remediation workflows of your identified risks. At a minimum, you'll likely want to use native API integrations in order to orchestrate policy violation remediation information and actionable guidance to existing ticketing and workflow systems, such as ServiceNow, Jira, or within your security and risk management ecosystem, such as Splunk. A key advantage of your policy as code is its ability to enforce automated security compliance checks early within your development processes. This prevents risky infrastructure as code from ever being deployed in the first place. In my last example, I'm going to look through the lens of an application developer. Shifting security left has been difficult due to diverse developer journeys and security that can become invasive to implement. However, with correct automation of policy as code, you can consistently enforce those policies anywhere within the CI/CD chain without impacting the developer experience. This enables both security and agility during the development process. In this example, a developer is using Visual Studio to commit code changes about an Amazon database service of RDS. As she makes a code change, the infrastructure code is being automatically scanned on the repo server level and checked against a series of policies during the commit action. At this point, if policy violations are found, the developer receives immediate feedback on what changes are required in order to bring her code back into compliance. As you can see, there are a number of configuration settings that must be changed related to this DB cluster. These are related to the PCI policy for encrypted data, which means a change to both the KMS key and storage encrypted values are required to bring this code to compliance. So let's look at what we learned today in our session. First, since policy is becoming a de facto standard for assuring safe cloud usage, automation again is the only way security can keep pace with your application delivery, and for that, policy as code is essential for controlling the cloud risk. Second, managing a growing library of policy content and quickly baselining your risk posture requires a system to easily catalog and manage your blueprints and best practices. Third, customizing controls is critical to ensuring your safe cloud usage. Write your controls within the cloud provider's native language and use automated tools that let you quickly adapt to changing cloud services. Next, avoiding alert noise and reducing risk, as the automate policy enforcement requires context and the ability for different parts of the organization to apply controls that meet their specific needs. And finally, policy as code opens the door for automating security and compliance checks at every stage of the cloud application lifecycle. This requires you to have frictionless guardrails for developers and visibility and control for the security teams early in the development cycles. I hope you enjoyed today's session. Please stop by our stand or visit our virtual booth if you have any questions, or to learn more about operationalizing policy as code at scale.